All right, welcome back to Lab 2, Build Your VPC and Launch a Web Server. I'm Richard Golson, and I'm going to take you through task 2, create additional subnets. In the previous video, we looked at or created a lab VPC, and we can see the resource map here, which created quite a few resources, including subnets, route tables, internet gateway, and a NAT gateway. So all of that was created in a single availability zone. Now we're going to create the second availability zone resources. So we'll create 2 additional subnets for the VPC in a second availability zone. Having the subnets in multiple availability zones within a VPC is useful for deploying solutions that provide high availability. In this case, the high availability is provided by redundancy. So after creating the VPC, as you've already done, you can still configure it further, which is what we're going to do by adding more subnets. And each subnet that we create resides entirely within this one availability zone, the second availability zone. So what we're going to do is go to our subnets in the navigator. We can see we have the 2 subnets in the US East 1A availability zone, a private and a public. And we're going to replicate that in a second availability zone. So we'll click Create Subnet, and it looks a little different than what we saw previously. I want to select the VPC. When you're creating a resource like a subnet, it can only exist in a single VPC. It cannot span VPCs. Down below here, now that we've selected that, and it shows the CIDR block within which the subnet will reside, we'll come down here and provide a name. In this case, it's a name tag. So I'll go ahead and copy that, and I'll paste that in. So tags are key value pairs, and the key is name, and the value is lab-subnet-public2. Very nice that we've got this number 2, so it helps us keep clear how it's different and distinct from the other subnet. If we gave it the same name, we'd be confused by it. We'd have to look at other information. Now, the availability zone is important. I do not want to create it in the same availability zone as public subnet 1. So what I'm going to do is come in here, click on it, and I'm going to choose the US East 1B. Now, please note that it actually has an ID that says USE 1-AZ6. So it looks like it's availability 6. And in fact, it is. But this is the relevant part for us, just a little background information. In order for AWS to load balance its resources, all of its customers' resources across all the different availability zones, it provides this tag. So when I choose a US East 1B, I'm going to get instead placement in AZ6. For me, it doesn't really matter because all of the availability zones have the same low latency links. And so that isn't going to create any kind of issues for me. Otherwise, everybody would put everything in the first 2 availability zones. You'd overload those and nobody'd be putting resources in the others. So this is how they're able to do this. So I'm going to go ahead and select this one here. All right. So note that I've got this set for the public 2 as the tag. This is going in US East 1B as expected. And then I need to set my IPv4 CIDR block down here. So this is showing me the VPC block. What I want to do is set the subnet block. So I'm going to go ahead and type this in, or copy and paste this in. When resources are launched on this subnet, they'll all begin with a 10.0.2. The 24 defines this last octet, this 4th octet, as the host portion. So any device in that subnet will have some number that's within the range of this, and that range is approximately 0.6 out to 0.254. Don't worry about it because we're going to allow it to automatically address these. That's what we've set up the VPC to do. It provides automatic addressing, so I don't have to do that manually, right? So it tells us that there's a possibility for 256 IPs, but we'll get less than that, 5 less than that. Here we can provide more tags. At this point, I could create another subnet by hitting add subnet, but in the lab, they want us to do it a couple times just to get some experience. So I'll go ahead and hit the create subnet. And I can see that it's created here. And if I select this, I can just review to make sure that the information is correct. Or I can go back to my VPCs filter it for lab VPC, and take a look here, take a look at my resource map, and I can see that that was created. And then if I show the details, it'll show me the information. And currently, now that I've created it, it has a route table association here. And that route table, although this is a public subnet, doesn't have a route to an internet gateway. So we'll be correcting that later. It only has the local route, but I can review things here as I go if I like. And so what I'm going to do is create another subnet. Also note at the top here, it's telling me that I completed that. So we'll create the subnet. And again, we're going to go ahead and select the lab VPC. And then complete this. Same availability zone. And here I'm going to induce an actual error here. So what I'm going to do is I'm going to set this to 2 so that it overlaps with this one intentionally. And let's watch what happens. I'm going to create subnet and I get an error. The CIDR address overlaps with an existing subnet CIDR. This is the one I created earlier. So it's going to prevent me from creating subnets that have overlapping address schemes. So I'll fix that right there. And I can create my subnet. And now when I come over here, what I want to do is update this, select it, and go to my resource map. And you can see I've created my private subnet. Note that it's using the same route table as my public. One of the things that we've learned about with subnets is the routes that are available in the route table determine whether it's private or public. At this point, since this route table only has a local route and does not have a route pointing to a gateway, you can see that here by showing the details, only has the private route. Therefore, both of the subnets are in fact private, even though I labeled it because it is a name tag, so you get to do that. It's still private. This one is still private because it doesn't have a route out, so we need to fix that. And we may be changing this as well. So we've created this. So that route table contains the rules called the routes that are used to determine where network traffic is directed. And we never really looked at the route tables previously. So what I'm going to do here is take a look at this public route table. I'll select that there. And if we look, we can see that this route table has a route for the network. So that's our local for the VPC. So we'll get that. All route tables have a local route. Not all route tables have a route destined for resources outside of the VPC. If I come to my route tables here, we can take a look at an example of that. Let's filter this for lab VPC. And we can see here's that route table. I believe this is the one we were looking at earlier. And if I take a look at here, this one, it's the one that doesn't have a name tag, right? It's being used with lab VPC. And in fact, I believe this one is what's considered the main route table. So whenever you create a VPC, a route table is created with VPC, and it's called the main route table. And that main route table always has the local route. And until you associate subnets with it or with other route tables, your subnet associations are considered without explicit associations. And we can see these are the two new subnets that were implicitly associated with the main route table, because at the time I created it, it had no way of assigning a route table to the subnet. Subnets can only be associated with one route table. You cannot use multiple route tables with a subnet. So we're going to be making some changes here. So we're in the route tables, and so let's go ahead and select the RTB private 1 US East 1A. Okay. So here it is. So that's that private route table that has only two routes, the local and the route destined for resources outside of the VPC, pointing to the NAT gateway. When I look at my subnet associations, I can see that only the one subnet here in US East 1A is associated with it. And there it is. We still have these two without explicit associations, which means that they're associated with the main. And because they're without explicit associations, I can associate them to any of the route tables. One more time about the reminder of what that NAT gateway does for us. The traffic destined for the internet is being sent to the NAT gateway. The NAT gateway then will forward the traffic to the internet. So that route table is going to be important for a private subnet. So what we're going to do is edit the subnet associations. And we're going to select the lab subnet private 2, this one that is currently not associated with the route table. We're going to associate it with a private route table that we have here. So let's edit the subnet associations. And what we want to do is add the private. Let me try that again. We're going to do it from here. This is a little safer if I do it this way. So we'll go to the subnet associations. I should have done it from here. We're going to edit the subnet associations, and we're going to make sure that we add the private 2. So we ensure that we associate it with the route table that we're using explicitly for the private subnets. So we can see that's there. We'll save it. So now when we look at subnet associations, we can see both the private subnets are associated with that route table. All right. We're going to do the same thing for the public. So I'll go ahead and take care of that. I'm going to go off camera and then come back. I'll show it to you. So follow the same path. See if you can do that. So here you can see that the RTP public route table now has both public subnets associated with it. That means that both subnets have a route out through the internet gateway, both public subnets. So now when I go back to our VPC console here, and I'm going to refresh the view, go to my resource map. And if we take a look here, I'm going to go ahead and select the public here, and you can see it has a route out through the lab IGW. And then when I select the second public, it also has a route out through lab IGW, the internet gateway. When I select the lab subnet private 1, it has a route out through the NAT. And the same thing with private 2 has a route out through the NAT. So now I've created the appropriate associations. Traffic will be able to flow out from all 4 subnets as needed and appropriate. And traffic will be able to flow into the two subnets in the two private subnets without being intervened by a NAT gateway. So at this point, we're ready to move on to task 3. So I'll see you in the next video. We're going to create a VPC security group.